Right, hi everyone, and welcome to the very last of the 2001 Technical Workshop Series under the ASEAN FAW Action Plan. My name is Alison Watson. I'm very pleased to be moderating this session, and I'm joined by Dr. Ivan Cruz from EMBRAPA in Brazil today as our expert speaker. I also have the ASEAN FAW Action Plan project assistants, Putra and Dika, as well as Randolph Condano helping on this workshop, and you'll see them here in the videos. So today we're focusing on the experiences of smallholder farmers in Brazil using biocontrol to manage fall armyworm. And we're lucky enough to have our international expert on this topic who has many years of experience of fall armyworm management in Brazil, Dr. Ivan Cruz. And Dr. Cruz will present in blocks. What he will do is then split up the presentation and have time for questions and answers throughout his presentation. So this is your opportunity really to ask as many questions as you can from a real expert on this topic. So please do so. And the way to do this is really by using the Q&A box. If you can put all your questions in that Q&A box, it really helps us to facilitate the session. That's where I will go to when I want to ask questions to Ivan. If you want to share any research links, publications, general comments, thank Dr. Cruz for his fantastic presentation. You could do that in the chat. And we really encourage you to introduce yourself and say hello in that chat box as well to everyone. If you do have any technical problems, then what you could try and do is actually just send a message to Grow Asia in the chat box. We can't do too much often if you've got bad or poor internet connection, but we may be able to help. And also what you can do is try logging off and on. That's my go-to fix if something doesn't work. Now, this is a fantastic slide just because it shows all the work that we have completed over the last 10 or so months. This is our 9th session, which is quite unbelievable. It's gone very fast, and we've got a huge amount of resources and knowledge that we've shared across these 9 sessions, or 8 sessions so far. And I'd really like to thank all the wonderful speakers and the organisations who have contributed to all of these sessions so far. It's a fantastic resource, and I encourage you to go and watch any of these sessions or download the PDF of the presentations on our website at the ASEAN FAW Action.org videos. And today we really end with sort of an integrative workshop because Dr. Cruz is going to sort of tie together many of the messages that we have heard across the whole session. So it's a fantastic opportunity to sort of finish on. Now, what we also encourage is to grow our community of learning and also talk to each other. And if you want a participation certificate, this is also really important, because if you can go to www.aseanfawaction.org, click on community, you can go to a forum, and there's a forum there for biocontrol. And we really encourage you to share your thoughts on this session, ask any questions, and also share any of your resources with the community at large. Right, I'm going to launch a poll right now, and this is just really to get to know each other, who's online today. It'll help Dr. Cruz as well sort of know who's around, and we're really interested to know as well how many sessions you've been participating in. So the first one is, what stakeholder group best describes the organisation you work for? And you have quite a few different options there. And the second question is, how many workshops have you already participated in? And I'm already seeing that over 30% of you have done 5 or more workshops, which is incredible. I'll just wait till a few more people have participated. And then I'm going to end the poll. Okay, and just so Dr. Cruz is aware as well, we seem to have a pretty good split, even split there between research organisations, government representatives, and the private sector. It's around 30% each. So that'll give you a bit of idea of who's on board. And just so you know, we've got 32% who have spent their time over the last year, 5 sessions at least on the biocontrol. So we've got a really good amount of people who have followed us through the whole sessions. And welcome to all those who have joined us for their first time. Excellent. So what I'm going to do now is I'm going to move on to the main part of our session, and I am very pleased to introduce Dr. Ivan Cruz, who's a senior researcher in the Brazilian Company of Agricultural Research, EMBRAPA, where he serves as the Head of Research and Development and Chief General of EMBRAPA Maize and Sorghum. Ivan has a Master in Integrated Pest Management at Purdue University and a PhD in entomology from the University of Sao Paulo. He's experienced in agronomy with emphasis on plant health, working mainly in the area of integrated management with an emphasis on biological control. And he's very passionate about this topic. We've already had a pre-discussion before we came on today, and I'm really excited about this presentation and hearing from him with many years of experience with fall armyworm. So Ivan, pleasure to have you on board and welcome. If you could load your presentation, that would be great. Just stop my share.
That's okay.
Just try it again. I can see you at the moment.
Just a moment. I really don't know what happened.
That's okay. We practiced it before, but I'll just see if you should be able to share now.
Yeah, but well, just a moment. Should I enter again?
Yeah, try sharing it again.
Okay.
It may have just been because I had my presentation still on. So if you relaunch the share. And it should come up. We do have your copy anyway, so.
Okay.
No, I see you at the moment. You're looking great. But
now let
me see. I'm just going to share my screen, and then I'm going to stop share. And could you now share your screen?
No way. Are you seeing me now? The presentation?
No, I can see you.
Maybe you're supposed to go back when I'm share. One moment. That maybe I'm going to share again the screen.
Yes, exactly. Yes, that's perfect, Ivan.
It's okay now?
Yeah, once you click on, I just need to, that's it, perfect. So now it just needs to be full. Excellent, thank you so much and welcome.
Okay, first of all, I should say good morning for everyone. And for me is good night. It's almost midnight here in Brazil. But well, I hope that in this today, you can discuss a little bit our experience in Brazil with the control of Speedopterophysia in corn or maize. Well, I just put this, my lab here. This picture represent the trichogramma wasp, just living from a fowl armyworm egg. But anyway, and this is the place where I work in Brazil, in EMBRAPA. Well, my initial remarks is for the farmer, saying that think carefully before deciding to use chemical in family farmer area, especially in family farmer area. There is no silver bullet against Speedopterophysia. And I should say, do not increase the degree of resistance or create a resistant pest. Application error may increase even more pest resistant level and certainly negatively impact the population of beneficial organisms. Avoid the use of the chemical insecticide exactly to give biological control agents the opportunity to adapt to the new host of prey. So it's very important. Anyway, if you're just talking about IPM, necessarily aim to reduction and maintain of the pest population to an acceptable level. Also, do not cause a negative impact on natural biological control agents. You do not cause environment contamination, including all living organisms and research in it. The success of IPM of Speedopterophysia in Brazil depends on knowledge about population fluctuation through the years. And the second question is, what is the best tool for monitoring Speedopterophysia? I'm going to show you three situations, different situations. And these three situations, the farmers is using in Brazil. The first one in the left is a pheromone trap. In the middle is a scraping on leaves, the damage just caused by newly hatched larvae. And in the right is the symptom of damage, like as some holes on the leaves. Often, unfortunately, the farmer does not have or does not want to use the pheromone trap and use the symptom criterion on the leaves. It's not a very good way to go. Just because, look in these two pictures here. In the left, infestation before spraying, just before spray. When the farmer look at, and AF is a pheromone trap, FR is scraping on the leaves, and FF a hole on the sheet. Look, when you use pheromone trap, if you go to the field and they say that if you capture 3 moths in your trap, you have the economic injury level, and it's supposed to go in the field at least and find a maximum of 10% of infested plant, like shown here. But also for the other criteria, it's supposed to be also 10% of infestation. Here, using scraping on the leaves, the farm say, well, I have exactly 10% of scrap on the leaves. But in reality, it's not 10% of infested plant. Well, the reality is that the infestation is over 40%. If you use the 30 criteria, the hole in the sheet, the farmer thinks, well, I have 10% of whole plants having hole on the sheet. In reality, he has 56.7% of plants that have at least one larvae. Well, it's interesting because you see, well, when you don't use the pheromone trap, you have a lot of the infestation is much higher. And also, probably, not probably, it's for sure, the development stage of the larvae are bigger than when you need to apply any chemical product, for example. In this case, considering the before spray, if you just spray here in the right side, you can see the infestation after spray. If I apply using in the plots where you have pheromone trap, the new infestation dropped from 10 to 0.9%. And if you just use the scraping on the leaves, the infestation 43.3 drop by 11.7. And this red line means the level where I should control the pest. So in using these two criteria, you apply chemical pesticide, but the pest is still over the economic injury level. So for is here, we demonstrate that you can do that. You must use the pheromone trap. Obviously, for the same treatment, the larval mortality is much highest, and you use the criteria of trap, pheromone trap, and you use the other criteria is not good. And if you look at the last picture here, this is the increased corn yield. Well, even in the other criteria, you get some gain in yield. But look, when you use the pheromone trap, the gain is much higher. Well, one thing is interesting, how the farmer should set up the traps. You use here in Brazil one trap that covers 5 hectares. And this trap is put in the field just before planting the corn. And also, the level of the trap should be 1 meter above the ground surface. This is the agronomic process to use traps. And look, this is one picture showing data on daily capture of moss. This line, the blue line, means it accumulates 3 moss per trap. That is economic injury level. Look, this is July to June, 1 year, for several years. The Speedopterophysia moss fly basically every day. And if you put here any planting data, you're going to see that you have much more than the minimum necessary to cause damage. So how to control the pest like this? Look, if you just plant in May by September, well, let's go to the next slide, because this is a daily capture. But the more important thing is the accumulated number of moss. If I just say that you use 3 moss is economic injury level, look at that. If you just plant by October to December, we started the planting time having in the field almost 80 moss per trap. So it's too much. And just for reflection, how many spray would be required through the year? What would be the loss in income if this pest is not properly controlled? When you're talking about chemical application, usually you apply 1 or 2, but the pest continue to eating for a small plant, even in the ear or in the tassel. So this is why most of the time the farmer is not happy with the result of the conventional control. Well, there is another reason. I put some crops here that the Speedopterophysia like too. obviously like a lot of corn. But look at this. I really don't know in Asia, in the farmer, how many of these hosts is cultivated in this region. But anyway, all of this is easily found in Brazil. Besides the food, so much food, climate condition and abundance of food favor the pest, for sure. Well, without the natural biological control agent of the pest, corn yield is greatly reduced, depending on when the farmer use control measure. I'm just putting this data here just to see when you use an exclusion cage to eliminate new infestation and also eliminate natural enemies. And here you force inside this cage, you have only one generation. What happened? Look at this graph here. Spray time after infestation, 2, 4, 6 to 16 days. Look, this is grain yield, kilograms per hectare. Look what happened. So, but when you farm say, well, how many times should I use one control measure here that I can protect my yield? Look at this. You just make a calculation about the cost of that curve. Look, when I apply the chemical pesticide 4 days after infestation, you get the best situation. This is a net gain. Just you compute the chemical pesticide, compute everything. If you apply in this situation 4 days after infestation, the gain per hectare will be $53.1. But if you delay a little bit and apply 80 days after infestation, the red number mean they are losing. In most of the time, the farmer is losing when apply the chemical pesticide because, as I told you before, the farmer do not use the correct monitoring procedure. So most of the time, he's going to lose. Well, beside the technical condition, there is also an environmental factor that just tell us that you should move for another kind of control. Another example, interesting. Look, again, in this experiment, you put the trap. Planting time, July 7, trap, July 20, 3 male per trap capture in July 24. You spray 1, August 3, because when you use trap, you're going to apply chemical pesticide or even apply virus or BT. You just get the economic injury level and apply 10 days later, because if you do that, the larva is the best size to be killed by the chemical or biological spray. Here, just to show you, this blue line is the economic injury level, and here is a check, is a natural infestation in a check plot, and the chemical M, here a chemical Z. Look, as the time goes through, we start to, in the case of the check, when infestation, infested the plant, about 30%, naturally, the infestation is going slow down, and after that, increase again. Okay, it's natural because the insect is just growing, become a pupa, and become another population. In the case of the chemical M, they just apply, they drop the kill the insect, they drop the population, but the residual effect is only between 11 and 13 days. In this point here, the population again demand control, but the farmer, they don't control anymore, because as the maize plant grows, it's hard to identify correctly the damage symptom, because the insect is inside the word of the plant. So again, so you see, in this case, the farmer is supposed to put another application. Is it the same for the chemical M or chemical Z? Look at this, it just drop a little bit, immediately the population goes up. Another fact, well, as I told you before, in uncontrolled witness, natural reduction in the pest population, but still above the economic injury level, probably by the elimination of natural biological control. Chemical, for, as I told you, after 11 to 13 days application, there is no effect of the product, and corn area will be infested with new egg masses and larvae that did not die in the first application. But the farmer is not, he's not thinking in apply anymore. So you're going to lose money because he paid for the chemical pesticide. The chemical pesticide was not good, but the larva is still there eating and reduction the yield. Here you can see what I'm told. I'm just saying. In Czech, if you look at the distribution of larvae by size, you see Czech, you have 36.8% the larvae is 0.5 millimeter, 10 centimeter, 10 millimeter, 10.5, 31.6, 21.2. You see, as the time passed through, the insect become bigger. So you must adjust the chemical dosage. So you increase price and you upset more the environment. So remember, here is the day after the second spray. So you're supposed to apply again the chemical pesticide, the same product. You see, the black line is for Czech. Look, again, here is economic injury level. But look at this product M. They don't have any more action. And this water here, Z, is the worst product. You see, you apply, but they don't kill the pest. And this according to all country. There is a lot of chemical application, but the farmer continued to lose money, lose corn yield. And I know that the failure in traditional controls Speedopterophysia, you can summarize in incorrect time to enter control measures, is spraying without considering plant or pest size, water volume, nozzle type. There is no monitoring, incorrect product choice, elimination of natural enemies, lack of knowledge of natural enemies, in pest population resistant to the insecticide applied. I know this very well because I travel many times for Africa, and in the first time, there is a pressure to put too many pesticides. In some country in Africa, the subterranean water is very close to the surface. So it'd be a terrible thing to apply chemical pesticide there. Well, if you have any question here.
Hi, Ivan. Yes, you have lots of questions. Obviously, you've already caused quite a bit of interest. And I guess a quick question here around pheromone traps. How do you get farmers to use pheromone traps? I mean, you've just outlined how important and useful they are. So how do you encourage farmers to use them if, as you're saying, they don't always want to use them?
Well, maybe you want to talk in the next topic.
Okay, excellent. That's a good segue for that one. Here's a question from Julius. What is the difference between, I guess, integrative and biocontrol for fall armyworm? I guess integrated pest management and biocontrol.
Well, I should say that we can do IPM using only biocontrol. IPMs using more than one measure that can do the work. But if you look at the history of IPM, it just arises because of the chemicals. This is different philosophy. But when you go to the field, you see, you are talking about here about fall armyworm, Speedopterophysia. So you're going to apply chemical pesticide and say, well, this is an integrated pest management. Well, apply the chemical pesticide, the pesticide just kill. There is side effect, kill natural enemies that usually maintain another species of phytophthous insect under control. So maybe you control a little bit the main pest, but other pests just to change the status, become a primary pest. And there is no way to get integrated pest management for a complex of pests using chemical pesticide. And you see, I understand that Speedopterophysia is a very important pest, but maybe most of you remember some years ago, the Helicobacter armigera come to Brazil, and there is no armigera in Brazil. You have Helicobacter zea, and the farmer just say, "Well, what should I do?" The farmer just buy a lot of chemical pesticide, and 2 years later, the Helicobacter armigera is not that problem because here, and we know this because Helicobacter zea, there is a lot of natural enemies, including trichogramma. So the Helicobacter armigera just cannot become a key pest here. So maybe it's a good question. Maybe when I'm going to talk about biocontrol, maybe you can just return to discuss this point.
Okay, excellent. Just a couple of quick questions. We've got lots of questions here, but I know you've got lots to talk about as well. What is your recommendation based on the number of males caught in the pheromone traps as the action threshold?
You mean the tree moths?
Yes.
Well, this is, you work in these for some years ago. You published a paper, the International Journal of Pest Management. And maybe you can discuss a little bit later because, well, you're just starting capturing moths every day. You just make some correlation with the yield, the number of egg masses, and so forth. And you validate this as I showed you before. Why 3? Because if you, well, obviously, you use the biology of the insect, the potential egg mass production by one female. And if you just consider quickly that one female has the potential to lay 1,000 eggs, so three moths, considering that you have 3,000 larvae. If you consider a maize plant, a maize crop with 15,000 plants, you consider that the number of infested plants is enough to reduce the yield, at least equal the cost of the technology to control.
Okay.
In summary.
Just quickly, here's another question. Applying, for example, you talked about applying 4 days after infestation, or within a short time period after infestation. But what is the meaning of infestation? Is it meaning you've reached the data scale 3, or when do you count infestation from?
You are talking about that graph, that I showed that 4 days is the best to control.
Yes, yes. So what do you count as, I guess, the starting point
of
infestation?
You see, in that case, you just isolate infestation and isolate natural enemies. So you put the insect, small larvae, new hatched larvae, and each 2 days we apply pesticide. What you say, when you apply the insecticide 4 days after the infestation, the maize is very small, the larva is very small, and they are killed easily. When you just some days later, well, the larva, in this case, for those pesticides that you use, they could not kill enough larvae to reduce the number of insects below the economic injury level.
Okay.
This, you see, this experiment is not so real because if you remember the fluctuation of the Speedoptera in the field, every day the moss is just come. But those pictures is due to show you are if you have only one generation,
yeah,
is one situation, but you don't have this because if you look at that second graph that they show the two spraying, you see you can have larvae, small one, egg masses, middle size, big ones. So it's hard to do that. So the reason is just because you have uniformity of the larvae and the chemical was well applied.
Okay. Just quickly, Ivan, because I know we want to move on, but I've got one question here that I think is quite interesting, because we have a big focus on maize, and I guess you brought up a table there of other vegetable crops and other crops that were impacted by fall armyworm. Graham from New Zealand says, I've only found it on corn and maize in Southeast Asia over the last 1.5 years since it arrived in Vietnam and Cambodia. So what are the real or true hosts? I understand it prefers grasses, but I've not observed fall armyworm on other leafy and fruiting vegetables yet in Southeast Asia. How bad is the impact on those other crops or vegetable?
Well, if I catch well what you're saying, you mentioned rice also. Is that right?
Yeah, no, I don't think we've seen really any, at this point, any real impact other than on maize. There's been a few anecdotal, I guess, observations of fall armyworm on other. I think there's been some attack on sugar, for example, sugarcane. How bad in Brazil is the impact on those other crops other than the maize?
Well, I should say that most of the time, someone increase the importance of Speedoptera on those crops. In the case of rice, there is another strain. The strain that we found in maize can eat and cause big problem in rice. The strain from rice usually don't attack maize. You see, now you are just seeing that sugarcane, there is no problem.
Okay.
There is problem in the cotton, because in this case, they are just feeding on the apple. And in the case of soybean, because Speedoptera is just eating in the grain, in the final season of the soybean. But as a leaf feeding, no, the maize is the one good host for Speedoptera. So you see, even you are worrying about these insects, maize is the real problem. The other crop, well, the insect can survive in those crops, but it's not usually, you don't put chemical pesticide to control on these other crops.
Okay, excellent. So Ivan, if you could continue on with your presentation, I know you've got lots of slides, so we don't want to run out of time. That would be great, and I'll just keep the questions going in the next section.
Okay.
Thank you.
Well, so you are proposing biological management of the pest in a participatory system. What I'm saying here. Well, you know that currently there is a strong global movement questioning the use of fossil and non-renewable resource in production system. There is a clear vision of the need to change the production system. So what I want really, you want to replace chemical, maintain the same level of control of the target pest and sustainable reducing environment risk. So this is why we implemented this new view to managing insects. And also, you must reconstructing wildlife beneficial organisms, but not only to reconstruct those beneficial organisms to control Speedopterophysia. No, it's just to control the complex of pests in the production system for maize and other crops. You should believe it. Quickly, I'm going to show this. I don't know if you know this kind of predator. It's very interesting for a nice surprise, because I make this film in Mali, in Africa. So there is a lot of insects that even we don't know if they are beneficial or not. Just believe that the natural enemies can do the difference. Well, this is a techno meeting on biological control in Mali. Mali has already a biofactory producing trichogram. This was interesting. I went there first time in 2010, and six years later I went back there. But what I'm talking about is this a network connection for quick information sharing, a very well trained actor and the beneficiary of the set. What I have here, I have a group of farmers. You have a platform, it could be WhatsApp. You have a biofactory consult. Here can be extensionists, researchers. And so you're training all these people, train all of them. Well, you should do this to control this Speedopterophysia or other pests. And once you get a decision about control, the farmer should act. What is, let me see. Well, this is a farmer biofactory of trichogram. But how should work this connection? First of all, there is meeting to register interest group, as I told you, farmer, consultant, scientist, biofactory, training at all stages of the program and promoting the empowerment of the all involved, a communication through WhatsApp to share immediately with the group any question, and there is one or more responsible to ensure immediately answer to the question raised by the farmers. So online training, and there's a connection operation. The tools is a pheromone trap, biological product will be trichogram and or the use of baculovirus of BT. You discuss a lot agriculture or agro-industrial process, or that is production and field insertion of the biological product, and protocols for monitoring, collection, and identification of natural enemies. This is a view, interesting view. You can work even in the 200 farmer. So once all farm are received training, I just put this farm here. They say, well, in my place, there is 3 moths, capture 3 moths, farm your moths. They go to the platform and everyone here, the all of farmer, and all the people know the situation for these two. And once this farmer get the economic injury level, the biofactory just provide the trichogram, provide the product, and also help to release in the field. Well, the best natural enemy that we have is trichogram. The reason for that does not use water, and you should save water, and leaves no environmental liabilities. It's a too good advantage. And there is high mobility. Insect easily find the egg masses. Once they just to find the egg masses, they put it on eggs, and the control, the efficiency of control is very high. And the farmer can just find the success of the control just because 4 days after parasitism, all eggs get black in color. But you also have the Telenomus remus, that's very good. Both are very good. Trichograms is easily to produce in biofactory, and the Telenomus remus is a little bit more expensive, but both are very good. Just showing this active, very good both. And you should consider that the number generation during this 150 days from corn cycle, Spodopter can give 5 generation in trichogram or Telenomus 15, 3 by 1. So this is one reason why this egg parasitoid is so efficiency. Well, depend on the area size. You can just use the trichogram by hand, but big area, in our lab, you just formulated the trichogram inside this capsule, and these are applied by drone. And we know in the case of space, you just make the flight plan and say, well, just release 1 capsule in each 16 meter, and go to the end of the field, turn on the left or right, just fly 25 meters and go back doing the same thing easily. In a small way, you see here, you say the drone, just applying easily. Today is the farmer wants to have this because they think yes for sure he's going to abandon the tractor and just move for this very small tool and cheaper tool. And that is what we're doing here to apply. There is a lot of way to apply trichogram. So you can just with discards, just impregnate this, also discard, or using in this capsule easily. In a small farmer just can do this, put in this vial, and just to wait the adult emergence, they fly and just to go and do the job easily. And one good advantage, why you can put this in points, only 20, 25 points. When you consider that when you're going to spray, you must spray in all plants. And just because they just search. So when the plant is very small, with speed, there is a gain in speed in the search for the eggs. And in general, you can just, the efficiency is much higher when the maize is very small. I believe that the trichogram as a social technology should be indeed applied in Africa, in Brazil, and in Asia, because when you put this insect here, you construct the population. So you maintain this product under control. And as I told you, instead of, for example, Brazil, we use to release 60,000 female by hectare. You change this a little bit. You say, well, instead of release the 60,000, just split in 3 times, applying just 20,000 female per hectare. Why this is good? Because you see, when you just release 60,000 eggs, parasitoid eggs, or adult eggs, or females, you're going to get a new generation 10 days later. So between the day 1 and day 10, if there is any egg masses between, there is no trichogram to control. So you split in 3 times. So you're going to have moss, trichogramma female here at 10 days later, 13 days, 16 days. So you just build up the trichogramma population. This works nicely. Well, the farmer can just check up if that is okay. Well, if there is 20,000 females, I'm sorry, it's in Portuguese, per hectare, and just go to the field and say, look at 100 plants and count the number of egg masses. If there is 8 egg masses, is enough to release this. If you release 40,000, you can just have a maximum of 16. So you can just easily check the safety of release the trichogramma female with the ability to parasitize 60 eggs. Well, when you release the trichogramma, the farmer notes the increase of biodiversity. In this case, I'm going to show you this picture here show 1 hectare. And the red dots, the red dot on the cobblestone represent the pest. And this man, forgive me. Now, the red point is the parasitoids, larval parasitoid. And the high of this cobblestone here is the infestation of larvae. Look at this yellow color, there is few red dots, but because the number of larvae is so low. But anyway, the farmer don't know this. So he'll apply chemical pesticide in this situation here, probably going to kill some of these insects, but it's going to be very bad against natural enemies. And why I'm saying that? Because here I'm showing you some 10 municipalities in Brazil, and at least 1, 2, 3, 4, 5 very, very good natural enemies, larval parasitoid. This red dot here is called Campoletis flavicincta. I know that Telonus insularis, maybe, I don't know, maybe after someone can say if there is one of these natural enemies in the Asia area. But you see, they are very, very common. So together with the release of trichogramma and with this larval parasitoid, why are you going to apply pesticide? If I have too much natural enemies, I'm going to put chemical to kill this, and the farmer become dependent on the chemical. No, you must just know your biodiversity. Look, remember that I'm just tell about this Campoletis flavicincta, this one in red. Look at here. This is 14.5 square centimeter is the amount of the consumption of food of this insect. When the larva is a healthy larvae, they can just eat 209 square centimeter of leaves. So there is a reduction in 93% of food intake, just for this Campoletis. And look here, one female can parasitize 200 larvae. So this insect, if you look by one by one is more efficient than a trichogram. So, but you don't have this insect in biofactories. Look quickly, just because how it's happened in the field. The very small wasp called Campoletes flavicinca. This is a male. All these small larvae are parasitoids. So being said, just look, when you find the female, there are some behavior differential behavior. The ovipositor is out, and the female is going to look for a healthy larvae and use the antenna just to see if it confirms if there is a healthy larva like this one here, and immediately put his egg inside. So you see, it is a very interesting biocontrol. This larva is really, there is no way because they're going to reduce the food intake. Another one, Chelonus insularis, a big one, a very big one, considering the eggs of Spodoptera frugiperda. Look, these two larvae here, they were born in the same day. So a healthy larvae and a parasitized larvae just before that. So there is a lot of case. Look at this, the tachinid fly, and in the case of this species, they put the eggs inside close to the head of the Spodoptera. Even we know that is a big one, but if you consider the maize is cultivated during all the year, so it's a good one too. So you have a lot of these. Also, it's interesting because you are interested in maintaining the chrysopods in the field because aphids, usually when there is some disequilibrium in the field, aphids come and you are just preparing also production this insect and release in a small farmer. Earwig is the best natural enemies that you have. This earwig is called Dorolutapes. It's not from Brazil, it's from maybe from Africa or Asia. I believe that's Asia. This insect lives almost 1 year, and they eat a lot of eggs and larvae of Speedoptera, Helicoverpa. Look the amount of egg consumed by one insect, just one insect. So Brazil now for the farmer, the small farmer, those farms that don't put chemical pesticide, just using these natural enemies to get a good job. While you have this Podisius, an excellent predator of Speedoptera, also is being here in biofactory. Using this insect, I don't know if it's common in Africa, the tenebrio. They use this pupa of tenebrio as a food source for this predator, Podisius. Very, very good to control Speedoptera. Então, you see, this amount of newly hatching Podisius. Well, also, Zelus is a species that is very important to control the Speedoptera. No, not only Speedoptera, but when this insect is present in the field, usually the damage of Speedoptera do not demand control. I just put this, I don't know if it's common in Asia, but this is the egg masses. And usually you just hatching this small larvae is interesting because you need in the connection, a communication. Usually the farmer think that this is a pest because they don't know, because the appearance of these insects is different from the others, but they are just the newly born, newly hatching Zelus, just sucking this newly hatching Speedoptera. And you are working also with all these lady beetles. Harmonia. I believe this Harmonia comes from Asia too. It's very nice to eat in eggs of Speedoptera. You see, they eat a lot. And interesting because you are just hearing these lady beetles using this is Anagasta cuniella, this is the egg that you use to produce trichogramma. So in the fact that you produce trichogramma, you can also produce the ladybugs. So you can just produce more than one species with the same food source. This is another one. The insect, Periopsis connexa, another ladybird, very interesting. Well, just to finish, I say it's very interesting that the farmers should think about the conservative biological control. And you use in Brazil the Mexican sunflower, but in reality, I believe that this is from Africa. Africa had a lot of this plant. Well, just to finish it, I say if farm eliminated the biological control agent, you will inherit their labor, which was free. Well, thank you very much. I hope that you could understand a little bit, at least reading the slides. But now, if there is any question, I'll be very glad to talk to you. You see, basically today, the Brazilian government just create the national program of biological input, and exactly to increase the number of commercial brands of the biocontrol. In the case of insect, for sure, a trichogramma is one of more useful in biofactory. And this is the reason why you talk too much. You see, this small insect here is Telenomus remus. This is a silk, maize silk. But you have a lot of this insect too. Okay, thank you.
Thank you so much. I mean, that was an incredible presentation. There's so much detail in there. And just to assure everyone, you will have a copy of the PDF. It will be shared, and also the video. So don't worry, you'll be able to go back. And you've got lots of great comments already, Ivan, one of the best presentations, somebody says. So we've got lots of questions and good amount of time to ask them. One of the questions here is about the natural enemies. You talked about how sometimes farmers might perceive some of those as pests, so that you need some sort of educational communication to inform farmers about the benefits. What do you think works best in communicating that to farmers? What's worked best in Brazil, for example, to try and teach them about the beneficial?
Well, you see, okay, when you bring together all those people that work with maize using the connection, you discuss all of these, because when you put the WhatsApp, you have a bank of data and picture about past natural enemies. And if you recommend that the farmer, they just take picture all the time and immediately put in the WhatsApp. And there is in the other side someone, they say, well, if you don't know this species, if this species is not in the cell phone, well, they're going to input this insect, and the correct name is A, B, C, D, and is a natural enemy and should just preserve. I don't know if this is the right case, but you have a very nice program of communication. But the communication started much before. In the connection, you say, sit down and say, let's discuss in the lab, go to the field, know the eggs, of separate eggs of the pest from eggs from the natural enemies, and so forth.
Okay, so it's really important to include farmers as a central part of that communication, and actually, as you say, really talk and discuss what's actually happening in the field. I've got a question then on that. Which ways are more effective in making farmers have access to natural enemies? Whether should they rear it at their farms, or should there be certain agents selling the products around the farms?
I ask you to repeat for me.
Yes, sorry, no,
You're saying-
I'm reading the question. No, I think this is an example where you're introducing natural enemies to the farms. What do you think works best? Is it for the farmers themselves to rear these natural enemies in say little biocontrol factories, or do you have agents who produce them and then sell them to the farmers? What works best?
Well, if you look at that connection, you are just telling the farmer to get your own biofactory. Because today Brazilian government is favoring the farmer, or at least not an individual farmer, but an association of farmer, and the research institutions such as EMBRAPA help a lot. So while you say, well, but this is not the case, because you've considered that the prices of this natural meat is not so high. It's the same of the campus side. So what I say, well, trichogram is the best to use, but there is the only one. So those people that participate of the connection, they receive in the first year, they receive for free the trap and the pheromone, the trap and the trichogram. So they receive for free.
Oh, excellent.
By the time when you take the decision to use, the extension people go together at the farmer place and both release and make all the measurement, make the evaluation, show the blackish of the egg masses. But this isn't a second step, because much before in the capacitation, they learn about that. So if you look at the slide, one thing, but if you look at the field, it's another thing. But without this connection, one by one farmer, they don't do nothing correct there. This is one problem, because there is a lot of people that say to farmer, well, look, if you don't apply this product, you're going to lose. And the farmer just go and apply the product. So the task is not so easy to get the biocontrol. But if the farmer learn and know one insect, and when he see this insect in his place, well, it's good. There is one thing I don't know about in Asia. Usually, when the farmer is a woman, the woman usually accept much easier the biocontrol. Usually the man is say, well, if I'm use this biocontrol, my neighbor is using chemical, but you are just change. We select, first of all, a small farmer producing only maize for grain, but also those farmers that use the grain or the maize for cattle food, for milk production. So they don't want to put pesticide. So this is and once you get a good result, as a matter of fact, one case that you work with this farmer to produce forage of the maize, the result was sent to the FAO.
Yeah.
So you see, this good example that help to include more and more pharma. But
Excellent.
my constraint is that Brazil, there is a lot of people try to manipulate, avoid that farmers become normal, make use normally of biocontrol.
Yeah. No, excellent, excellent description. I mean, there's a lot there to digest. I've got maybe a bit more of a specific question here about the capsules. Yes, can you hear me, Ivan? Can you hear me now? Oh, I'm not sure. Ivan, can you hear me? Let me just see. I think we've just lost Ivan. I'm just going to check. Putra, can you hear me?
I lost you.
Yes, I can hear you.
Oh, Ivan, I can hear you now. Hi, thanks, Putra. We lost you. Don't go. No, listen, we've got so many questions. Here's a very specific question. It was quite an interesting example you gave about the drones and the use of the capsules. And two questions here. Does the capsule melt on its own after an hour, or do you need to open the capsule prior to release in the field? How does that capsule work in releasing the trichogramma?
How I release this?
Yeah, how does the capsule, because I think you had them in like little pills or capsules that you were dropping across the field. Does the capsule just break apart?
No, it depends on the size of the farmer.
Yeah, okay.
Okay, because you see, if you have a small farmer, usually you can just walk around the farm.
Yeah,
because exactly. If you consider by a hectare only 20 points,
2 hectares. Yeah,
just pick one capsule and put in the place. It's easily, much easier. Because the thing, when you spray, even if you spray baculovirus, for example, we need to have the tractor. You need to have the water. The fuel is so expensive. But
I understand that. But what is the mechanism of the capsule? I guess it just dissolves after a certain amount of time, or people just want to know how the little pill, I guess, disintegrates and when.
Yes.
Yeah. Okay. Okay. Another question here. We've got quite a lot, so we'll try and get through. Here is, I'm just looking because we've got a lot of questions. I'm going to try and choose a few. One is, actually a question around you said, which was very interesting, that the farmer is given a trap and is then given the resources and tools and sort of a kind of, I guess, selection of things to use for this biological control. Is that free? Are they given like a free lure and a free, or do they pay a small amount for that?
No, yeah, you see, there is two things. In the beginning, it's free.
Yeah.
But there is also the extension institution already is setting up the biofactory just to give for free for the farmer. Is in terms of extension institution or even some university. Okay. Just produce and give for free. My idea is that if the farmer need and they're going to use, for example, trichogramma, you stipulate a price and they can pay in grain. But just to maintain the biofactory, as you see, it's a public extension service.
Yeah,
it's not the private extension, but they get for free for the first time.
Okay.
Even the capacitation is for free.
Okay, no, that's a really good point. Listen, a question that we've had here is, but what about BT corn? What about genetically modified corn? I mean, how do we incorporate that with biocontrol? And can it? Should it?
If I believe that it's easier to get biocontrol for those people that is not a farmer, is just work with cattle. They accept more quickly that the common farmer.
Yeah.
If you consider big one. The thing is, let me just say to you, the big farmer has airplane to apply chemical.
Yeah.
Or have that big sprayer is almost $5,000. It's very, very expensive. When they are just a change, because today you can buy 4 drone in a small software that you control in 1 hour the application of 4 drone, each one apply in 100 hectares. That is, with 4 drone, you apply in 400 hectares. So it much cheaper.
Yeah. It's an interesting one about the drones. Do you think, therefore, I mean, drones can help reduce pesticide application because they can be more precise, but could they also end up encouraging more use of pesticide because they can do it more efficiently and faster? Are there's I'm just thinking, there's obviously great positives with the use of drones for precision agriculture, but are there concerns that we need to also keep in mind around the fact that they could end up being used to apply more pesticide? Yeah. What's your experience in Brazil?
Well, you see, first of all, our law is pressuring each time against the chemical pesticide. This is one thing. Biocontrol, if I catch your question, biocontrol, the only reason why you get success, you can just say it's just because the trichogram, just because it's easy, it's cheap, it's efficient, and you can just apply. There is one point. There is another point that I should mention. When in the biofactory, today you produce a dosage for 1 hectare, you used to pay $0.50, 50 cents. So very cheap. Well, in use as a food source for rearing the insect to produce the eggs, there is a waste. This waste material is a mixture of flour. You can just have a good opportunity to give this food for fish. Okay. And it's a very nice for fish. So in this case, you are just decrease the price. So I believe that this is the reason. Another thing that I should mention, because Brazil is small pharma, is also increasing so much the organic production. Yeah. And for this reason, we have today, only for maize, you have a solubilizer of phosphorus, you have the baculovirus, BT, and trichogram. So it depends on the type of exploration, field exploration. Obviously, for the big farmers say, well, I need the trichogram. Maybe the only big limitation of trichogram is that, well, I need it tomorrow. The biofactory can give me this. Well, impossible. So but we know you can just change, use low temperature and solve the problem. But I believe that in Brazil is what is going to happen, the distribution for several biofactories, because it's very cheap. Yeah. But I don't know, this is the right question that you asked me.
No, that's okay. That's okay, because it's extremely interesting. But I do have, just before we go, we've got a bit of a time pressure, and I've got quite a few questions about these capsules again. obviously this was of real interest, and we've got some questions here. If you could answer these quite quickly, Ivan, we've got how many parasitoids are in a capsule? Is it a gelatine capsule? And also, how many grams of trichogramma? Same question. Should we put per capsule? So people are really interested about this as a tool.
You mean how many what? How many?
So how many parasitoids or how many grams of the trichogramma would you put in each capsule? It's a very specific question here.
You see the capsule to use the drone.
Exactly, the little capsule that you're putting into the field. They want to know what's in there and how much of the trichogramma.
Well, you cannot put completely full. We put between 3 and 5,000.
Oh wow! Okay.
You see, if the recommendation is 20-25 per hectare, so if you 100,000. So if you divide by 20, is the best way is just 5. Exactly 4,000. It's okay. You should say interesting. I believe that the question could be, well, how many holes should have in the capsule?
Yep.
Well, you use 4 different holes in different space because the trichogramma, they don't like darkness.
Ah, okay.
So it just want to look for light. In this case, it's easy to see. Well, once they just emerge from the pupa, they just look at the hole and go away.
Okay, excellent. That was a superb presentation, but we have to draw it to a close because you'll be losing your voice soon, I think, Ivan, because you've spoken so much, but you shared so much of value with us. It's extremely valuable and important to sort of get those messages out there and learn from your experience in Brazil over so many years.
Let me comment something.
Yes, go please.
When I present one talk with for the plant-wise people from Pennsylvania State University, well, they recommend the people that still there is some question that could be sent me by WhatsApp all the questions, and immediately I answer all of them. I just apologize because I was talking with Alison. Yeah, there is a lot of difficulty for me to understand very well the accent. But anyway, I'll be here for any time.
Thank you so much, and you don't need to apologize. I have a very strong accent too, and that's part of working internationally, is to understand and communicate and take that into account. What a fantastic presentation though, Ivan. Really very appreciative of your time that you've spent with us. I know it's very late in Brazil, but I think it's a really powerful way of sharing our work and learning, is actually having people like you who have spent many years in the field working with smallholder farmers, sharing your learnings and experience with us. So thank you so much. And just before we go, I just want to, I'm going to ask Randolph and Putra, they're our project assistants in the ASEAN Action Plan, and I wanted to give them the opportunity today to each give 3 takeaways from the session. So Randolph, do you want to start?
Yeah, sure, Dr. Allison. By the way, thank you, Dr. Ivan Cruz, and hello everyone who are watching around the globe. I would like to emphasize the potential of biological control, since biological control is a practical solution for managing the fall armyworm, because it is environmentally friendly, it is socially acceptable, it is for humans, safe for humans and animals, and it is sustainable. The use of biological control for the control of fall armyworm has a host of benefits. In terms of location, the biological control agents are naturally found in the area, so the introduction does not pose a threat of turning a non-native species into an invasive species in the area or region. Second, in terms of cost, mass rearing the biological control agents is cost effective. In fact, we can establish a rearing facility in a village level involving farmers. And third, some biocon agents can be a natural enemy to many pests. So with this, with the use of biological control agents, it is important to determine the best or appropriate time to employ other control, especially chemical control, or do we still need to apply chemicals at all? And secondly, in terms of monitoring fall armyworm, since early detection is important to control the spread of fall armyworm, using specific pheromones, traps can be used to monitor target pests, and in our case, the fall armyworm. Please take note that while the use of pheromones can be used to suppress the male ability to locate females for mating and potentially reducing the number of offspring, pheromones are mainly used for monitoring. Please take note of that. And also, please take note of the different host plants of fall armyworm, because while we are controlling fall armyworm in corn, we also need to control fall armyworm in other crops, because these crops might be the source of fall armyworm that will eventually infest our corn. And lastly, let us relay this information and technology to our farmers, who are the one who really need this information. Thank you.
Excellent. Thanks, Randolph. Putra, do you want to quickly summarize from your perspective?
Yeah, thank you, Alison, and thank you, Dr. Cruz, for the great presentation. So some of the takeaway homes that I can take from this presentation was that there's no silver bullet for pest management. So understanding population dynamics is very important, and it's the first step for pest management, especially when you're using biocontrol in your fields. Number two is biocontrol must be explored. Like as Randolph has said, it is safe for the environment. They are naturally in the field. So taking advantage of those natural populations or even adding some would be beneficial. And then the third one is to enhance the success of biocontrol, effective communication, using medias that farmer uses, telling the right content, maybe these insects are natural enemies and these ones are not, and then building cooperations with these farmers in ways where they can easily benefit from these programs is very important for the success of biocontrol. Thank you, Alison.
Thank you, Putra. Thank you. And there's just two things that I really liked as well. I like the trichogramma as a social technology. I really like that statement, Ivan. I think use pheromone traps seemed to me a bit of a no-brainer. And it really helped with that early detection, which is critical, and that farmers are essential to the process. So look, just a fantastic seminar. Thank you so much for joining us. Thank you to everyone. This is the very last of our 2021 series. It's been a big one, but we've ended on a great note, thanks to Dr. Cruz. So please join us on our community through our forum. Please make any comments there. What I'm going to do is take a list of all the questions that haven't been answered today, and I'm going to try and get those answered and actually post them on the forum with Ivan and Randolph and Putra's help. So just before you go, please keep safe, everyone. Look after each other and keep up the focus on biocontrol and the passion for making change and helping our farmers in the field. Thank you very much, Ivan, for joining us. Thank you to Randolph and Putra as well. Good night or good morning, and have a lovely day. Thank you. And if you're still there, sorry, you are welcome to just do our poll, if I can find it, which I can't. Which I cannot do at the moment. So thank you, Ivan.
Okay. Well, let me only talk something. Biological control cannot be think only for Speedopterophysia.
Yeah.
I believe that biocontrol is a new way